Hello, Organized. Hello.
Good evening.
Very good evening, all.
Good evening, sir.
Hello.
Hi, sir. Yeah.
Kupre, how are you? Can you hear me?
Yeah. Very well. Very well.
Perfect. Thank you.
Okay. Generation, failure prediction, procurement analysis, risk estimation are some of the recent works being done for customers by him in the domains such as logistics, retail, railroad, insurance, and manufacturing. Prior to joining HCL Tech, Dr. Sai had brief stints with Excel Shop, Bharat Matrimony, and Suleika, where he was instrumental in making the respective organizations adopt AI and ML by building the data and insights driven applications. Semantic learning journey, mobile based assessment, semantic search, cross sell, upsell, and personalized recommendation were some of the applications he had developed. Dr. Sai has 12 granted patents and about 20 publications to his credit. He obtained his PhD from IIT Madras in 2005 for the work Large Data Assimilation and Dissemination. Dr. Sai's overall professional career develops academic also. His early years after PhD have been spent at Amrita Vishwa Vidyapeetham for a couple of years, where he established and headed the Center for Digital Earth. Another couple of years, he had served at an engineering college as Dean of Research and Development. Dr. Sai is a senior life member of Computer Society of India. He enjoys traveling and exploring nature with family and friends during free time. With this brief welcome note and introduction of the topic and the speaker, let me request Dr. Sai to enlighten us on analytics development lifecycle and MLOps. Over to Dr. Sai, please.
Thank you, Mr. Mohan, and thank you, organizers, at the outset for this wonderful opportunity. And thank you so much, all the delegates and attendees, taking time out on this busy working day. I know it's end of the day, and you've taken time out to spend time with us. So I just may share my screen and let me know. You're able to see the screen. Just let me know, is the presentation in the presentation mode?
We can see.
Visible.
Perfect. Thank you. So, once again, thank you, Mr. Mohan, for the kind words. But given the short time, and again, this is slightly like pressed for the time, and yet I try to have some placeholders and hopefully share some of the experiences that makes the time worthy of you. And then also I try to find the kind of secured place here, but please bear with some noise or anything around which is out of my control. So in today's deliberation, so what we shall do is to look at the analytics development and then even try to do a bit of etymological analysis on what is all this analytics development life cycle all about, and then perhaps get into the nuts and bolts of data and model, and then what perhaps needed to realize MLOps in the sense of continuity in terms of development, integration, training, monitoring. So then we'll also elaborate a bit more and spend some time on what we have in terms of offerings from different cloud players and different tools and technologies. Then, if the time permits, probably we can also just look at a few case studies, and then we'll have some knowledge share and then question and answers. So let me begin at the beginning. As I was telling the other day with the organizers, I wish it is more of in person so that we'll have more dialogue. But anyway, given the scenario, please bear with the monologue. And then so let me go, assuming you're virtually there and then you're answering the questions. So what is this ADLC, like, so the analytics development life cycle? So usually I love to take the inspiration from the life. And therefore, if you just look at anything around us and surround us, so we do see the cycles or the life cycles, right? The best example would be to look at the seed to fruit, and then the cycles are infinite, as we can see, right? So the seed, the sapling, the plant, tree, then you have the flowering, and the finally the fruit, again giving back to the nuts. So, but coming closer, so what we are more familiar is the application development, again has a life cycle, and more importantly, what we are all familiar from our student days to even today is the typical standard software development life cycle. So what perhaps is common with analytics development life cycle and what perhaps is different is what worth discussing some time and spend some time. Perhaps the of course cliche and known statement, and what is causing us to take the interest is change that is being constant throughout in several of these activities which we are taking up. So essentially what we are saying is, so the development life cycle specific to analytics has the element of change which is being constant, and then we need to fathom and we need to see how we can come to terms with this change, and then how can we make it integral part of the development life cycle so that the change is always being considered, monitored, and handled well. Then, of course, as we deliberate more, we'll also quickly look at a few nuances on what perhaps is common between the SDLC and what is being different from SDLC. So a simple etymological analysis, as you can see, right? The analysis and analytics is a very interesting thing. I don't know how many of the students are participating here and whether you were ever curious, right? So why we very specifically call something as analytics instead of calling it analysis, right? Why are we not calling something as data analysis? Why we are very particular calling that as data analytics, right? So that there is a purpose, there is a meaning to that. And the very reason why you want to call something as analytics is it is a good inseparable combination of analysis and there is an inherent modeling. So that is what is making the word as analytics for us And therefore, this is the analysis, and there is an element of modeling which is combining and allowing us to call something as analytics, data analytics, business analytics. So when you're saying something is analytics, you're very much knowingly or unknowingly ensuring that you would be analyzing something. So that could be your requirements, typically analysis. That could be your data analysis. So that is why the analysis is typically covering two dimensions. So the data dimension and the requirement dimension. So again, you can actually double click on it and say, okay, different types of data, different types of formats, and they can be business requirements, they can be application requirements, they can be system requirements. So all that is again the in our standard SDLC parlance, your high level design HLL and the low level design LLDs is what will be taken care. But in addition, probably from the first generation or 1.5 generation, just lack of better term, I'm just coining that on the fly, who were more focused on the standard, the requirements and the development. So the latest young generations, all the current students, and probably a batch or two earlier started focusing on what is called as this modeling, and which brought in the interesting word, the artificial intelligence, right? The cognitive sciences, which were taking backbench in say 90s on or even early 2000s to forefront. Why? Because the underlying compute, the underlying ability to process much, much larger data has become a reality today, thanks to the available computing in all your cloud services. And that is what added the additional block you're seeing here as modeling, and that modeling as innate components like, so you have something called training and testing, and you keep doing that several times, which you typically call it as tuning / fine tuning. And after doing all these train, test, tune cycles, once you are satisfied, again / once you met the task criterion thresholds, then you would like to deploy that specific model for further consumption. And therefore, now we come to the rightmost block. We are seeing 4 blocks here: the data, the requirements, the train, test, tune, and the deploy. And then I purposefully blocked something as the known SDLC, which was taking care of the requirements phase, the design phase, the coding / development phase, and typically the testing phase. So very interestingly, probably even when I was student or most of my learned colleagues, the seniors, I don't think they anytime very explicitly talked something as deployment. So we always develop something and we test it thoroughly. And the typical SDLC stopped there. They said that, okay, yeah, obviously after that your executables or whatever the code you have written, the code shall be used as needed. So they did not want to call a specific additional layer called deployment. And that's the reason why the similarity or the commons between your standard, the software development lifecycle to analytics development lifecycle, the requirement phase, the business problems, the high level, low level designs, all that remain same. And in fact, purposefully, I'm not bringing the other latest hype, like so the agile and the agile steps again, so adds a dimension, so which we are today taking the different approach, though the final outcome still would be a software product, right? So a software that is being used, that is being consumed by the different stakeholders. So the analytics development lifecycle is differing by bringing the 2 dimensions. That is, the development is now largely being governed, controlled, propelled by the data. And then it's also being controlled in some form or the other, the way that's being deployed, the way that is being consumed. So that is what overall now we shall be trying to understand and see. And the beauty team, why so we are spending a little more time on this is what the underlying crux of the analytics development life cycle in the abstract form. And the rest of the slides, the rest of the reading what you do, and I've tried to provide few the reference URLs, you can take a look at it at your leisure. But all that essentially talks about how exactly you are going to implement any of these blocks and then realize the kind of goals we set. So, but broadly, they do not go out of the blocks what we listed here. So the time and effort we spend would be either taming and tackling the data, or trying to extract the requirements and understand. And again, the moment I touch this, I can't stop. Probably all of you must have already attended a few other webinars on that, and today's hype, right? So it's all about Gen AI. So what is this generative AI is all about? It is nothing but trying to even eliminate or reduce the human interference with respect to extracting those requirements, giving those requirements, and then based on those requirements, generate the outputs. So even such a simple exercise, what we all got used to, right? The Googling/searching. Earlier, at least, we did a couple of more additional steps, right? So you gave a keyword, and there were a couple of hundreds of links there, and we have put a little bit of manual effort deciding which particular link should I click and what perhaps it is containing, relevant, not relevant. So we made few of those decisions, and today, thanks to GPT engine, thanks to ChatGPT, so you give, there is no second, right? So there is no second. So there is only one summary. You ask a question, you bingo, you get only one response. There is no second. Hence, there is no more analysis. So what it's saying is, I try to understand. The moment you give me a prompt, you give me a question, I understand what exactly is being implied, and perhaps I am coming as close as possible to you and giving the response. Hopefully, you are satisfied. And then that is being translated to the other facets, like the image generation, or the document generation, or even like the software generation, which today we fondly call as Copilot, right? The code gens and all these exercises are even trying to automatically analyze, understand your requirement, and then do the coding. And then it says, I'm even comfortably generating the required unit test cases, and then probably a few functional test cases. And I'm passing my own generated software and saying that, hey, this code is production ready. Very interesting to look at that, right? So, yeah, certainly the generative AI is, again, not an entirely different thing, not an entirely different beast, but probably the old wine in new bottle with a few more frills, whims, and fancies. All right. So, slightly elaborated or quick review, as I was saying. So, the analytics development lifecycle, if you take the practitioner's view, so they will elaborate a bit more, but still the important three blocks, I'm sure you can see great. The left block is talking about the data engineering, data repositories, data sets, and whatever related to data features. Then you have the intermediate heavy lifting. That is what usually we used to do so fondly and so much time. And again, I'm saying today, the Gen AI would like to alleviate most of the time, and it says, hey guys, I'm here to support you. So try to make me part of this experimentation and prototyping, and you start generating more and more code, you try, and then you derive the benefits. Then after that, you will be deploying that generated code and the metadata, code configurations, and invariably what comes with that is what is called as the version controlling, because you are going to develop several copies of the code and therefore maintain the version control. And then finally, you are ready to deploy those models, and therefore you like train and operationalize all that modeling part of it. So this is what any typical practitioner. So I'm reiterating that what is this analytics development and whatever it is encompassing between data, modeling, and the consumption is still remains as the underlying thread, common thread, but the kind of wrappers which are being generated and developed to achieve these objectives is what created different platforms, different tools, different technologies, different entities for us today. And that is what probably we shall be spending little time over next few slides. So before again getting into the actual platform view, since we said the change is constant, what is that change is constant? And again, so why the analytics development lifecycle is somewhat different from the software development? Because if you go back, or perhaps I can't again ask my younger colleagues for the reason they may not even be knowing the standard software development lifecycle, right? Because they are not even into the typical waterfall model where the requirements you gather today and you deliver the product, say, a year or two later, and then probably you start looking at the second phase of requirements. Today, we are nowhere there. Nobody is there. So no one has that much patience. And we are saying that the agile approach, right? So your teams are lean, and then your requirements come at most a sprint, 2 sprints, 3 sprint, and you say that as the terms stands, the sprint, right? It's running, and the running is not more than 2 weeks, and you hardly see even a 3-week sprint today. So within 2 weeks, right? So that is 10 working days. So a team of 2, 3, 4, 5, at most 6 people are looking to deliver, again, a newly coined word, what we have, instead of a product, a prototype, we are calling that what is called as an MVP, right? So the minimum viable product. That is what we will show. And that is when we start adding or enhancing the requirements, gather few more, add few more wrappers, and then make the second version of the product, third version, so on and so forth. Again, why I just touched upon that? So that change interestingly comes in different forms. So though I wish, again, so probably add a little more spice to these slides, so providing few animations. Sorry, like I couldn't add and spend more time to make this more lively and interactive. But I would request to extend a bit of imagination, right? So how the change comes in and why that is calling for the analytics development lifecycle to be watchful and look for what data is being generated. You see that there could be a sudden or abrupt change in the typical data cycle is certainly the key ingredient. And that has several, its own data lifecycle we have today, and it has its own evolutions, standards, whatnot. So I don't even want to really spend too much time on that, because there are people like who can actually like start talking about each of this bullet point itself probably as one session. So the data generation, if you're looking at, especially as I said in the context of Gen AI, so today people want the data to be generated synthetically, and this synthetic data should be fed. And remember, friends, that why that's so important today, like especially in the life sciences and few other domains. So you do not have the real data that is really required volumes, right? So because with the advent of deep learning and this Gen AI model, rare events that are happening, how will you make your systems test? How will we evaluate the systems? And that is where the data generation is becoming important. And the second important case probably would be in the IoT domain, where we know there are several sensors and different sensors generate different types of data, and understanding all the data and data characteristics is very, very important for us to model it. Then, of course, naturally, the data generation leads us to having the strategy and, again, the requisite tools. All of you must be hearing, right? Even earlier, we had these data privacy with Europe, and you even data, then fit to the model. Still, most of the AI, machine learning, and don't see a large portion of the machine learning, a large portion of the ML. Actually, we had the opportunity to work with, wherein once the model reaches and exhibits the confidence that, okay, my forecasting ability is able to part of the other biddings can be automated and is ready. But are we, you just sit relax? But leaving that to that confidence is very tough, friends, let me tell you. So if you haven't experienced, and if you have experienced, yes, very much. Dude, don't worry. So just leave me. You tell me what is the profit margin you want to make. The rest of the transactions I do, I don't know how many of us will want to make. The rest of the transactions I do, I don't know how many of us will leave that to that automated system. So and a lot of those difficulties, but somehow I am actually defense I have to that is today, with all the physical systems in place and process in place, still things go wrong. Why? Because especially humans and other life still takes the willful decisions to bypass, right? So that is where the error or the choice for error comes in. And then that's what need to be, again, avoided. Is a different topic to discuss some other time. And another favorite slide, and post which we'll get into more of the core, the MLOps and other stuff. But this particular slide, again, I want to be artificial intelligence. We, being the intelligent people, do we do anything else other than what you see on the screen? Probably you can put that in our chat windows and let the moderator take note of it. But I would say, at least with and take the stand from my point of view, is what you see here very comprehensively covers almost each and every action which we do. So every bit and byte we consume from our day one on this earth until date and going forward too, what do we do? So any information we take, right? So however the information is coming in whichever form is coming in, from all our senses it comes in, with all the data, what do we do? So we eat something and then say, what do? We classify, right? We only say it is good, it is bad, nice, not nice. So sometimes we say, oh, what is this? This taste seems to be something I'm familiar, but what is that possibly? So either you're classifying or you're clustering it, and you're saying that, oh, it's something like sweet, something like this one, something like that one, is what you say when we don't know the name, or otherwise we try to give a label. And that is how the clustering classification is still same. And I'm sure all of you would agree, right, with me that it's only a matter of whether it is a supervised model or unsupervised model that is being differentiated as the clustering or classification. And the other very important block are the data science, data engineering, or advanced data engineering, or analytics, whatever you call it, we do is constantly optimize it, right? So we always try to optimize it. So I'm sure even to attend this webinar, you must have done a lot of optimization, right? You say, oh, how will I finish my work and head to this place, or where do I stop and post this webinar? How will I go? And I know tons of optimizations we do from start of the day to end of the day. And again, it's the optimization cycle is what we keep doing with every bit of information what we collect. And besides these two categories, the third modeling which constantly runs in our head would be either regression or a kind of survival model or the forecast model, right? We're always having that single word called hope, and then we will start having lot of this forecast. Anything and everything we keep forecasting, and we say, this is what we predict, that is what we predict, this is how it should be, that's how it should be. And we keep doing this. And again, this is what makes, why again we spend a little bit of time on this, is essentially trying to look at any piece of data, any piece of requirement, any piece of problem business ask, and then translate that business ask into one of these groups. So we say that, okay, so if this particular business, based on this data, what is that they want to do that? So would they want to optimize the routes? Would they want to optimize the packages? Would they want to optimize the delivery time or the truck routes, whatnot? Otherwise, you are saying that all my financial domain, all my stock markets, all these other people forecast, right? So you would like to keep forecasting, and then you want to make some predictions, and you see how close your models are to those predictions. And the third class, anyway, once the data comes in, be it your network data, be it your usage data, be it your customer data, so all this data is what you would like to classify / cluster, right? You say that, okay, so these data is what I'm seeing as separate patterns, and put all these patterns into different bins and buckets, and then start developing the additional applications based on that classification clustering. So that's why I just took a little bit of fancy and said that, yeah, the models are the magicians, right? So they are the ones which are turning into your key data ingredient, and the magicians are working on that data, and here you go, what you get out is the magic potion, right? So you are getting that model output, and what do you want to do with that model output? So that model output, again, remember friends, so it's unlike the earlier days. It's earlier days in the first generation software. There are executables, and the executable will produce a sample set of data that is being straight written to your Oracle databases, SQL databases, or the simple flat files, and stop there. But today we have the requirement itself in the different ways, right? So how exactly you want the model to be used, and how we want to use the model outputs in different forms and shapes, though it starts with the basic desired formats like the JSON format, XML format, right, and CSVs. Of course, the other traditional text, again, no SQLs, and therefore we are bringing in several ways, and you store the data for your further manipulation. The next would be, again, most favorite form is today to show the live charts, right? Again, you want them to be near real time. So if you're making predictions, if you're making calculations, please showcase that. And today we have the digital cockpits that are showing in real time that how all our factors are performing, how each of the machine is performing, how the machine data is being generated, churned. And I know you must have heard of it. All these digital twins is an important and fascinating facet to know that any entity that is working, I will have the digital replicated asset on my system, and I keep seeing. And interesting, the digital twin or the digital asset has an additional function, because the physical asset only has a function to perform what it is, whereas the digital asset is replicating what the real entity is doing at this point of time. And also the additional thread, the additional compute is about, with all the past data, what possibly could go wrong, right? That's where one of the, say, survival model is sitting inside, and it says, hey, this particular bearing seems to be producing, so it seems to be good, but the bearing noise is deteriorating, and probably this particular machine's bearing is likely to go off in next 4 hours, in next 6 hours. And the digital twin is going to give you that insight, that alert, and immediately use that proactive alert to save time and effort, right? So you're prepared, and probably 9 out of 10 times or 8 out of 10 times, it's likely to go right. And that's what we have seen, in fact, and we could successfully implement that to a couple of customers. So I can more convincingly say that that is very much possible. So the digital twin can look at the data and give the right insights and actions and alerts. Then even the application integration has taken a different stride altogether. Whereas earlier, the models which are built in the heavy R form or with the, I don't even know again whether any of you heard an intermediate elephant-sized modeling deployment tool was there from Apache called Mahout, which did not really see much light. But those were the heavy ML models that could not be integrated well and gel with the other application environments. So they had short life, whereas today you develop these models, you have the several of the machine learning models which are very tiny and which can be defined as API endpoints, and then you can consume with ease all these the models in near real time and start seeing the benefits. That's the beauty today you have. Even with very heavy models, the final model can be capsuled and that can be defined as an endpoint, and you write a microservice on top of it, and that renders however the heavy application has been into a small form, and then you start scoring on your real data however quick you want to do that. So what I mean to say is the gigantic size can only be at the training model. The training model could be heavy, but the signature of your scoring model, the counterpart after training and testing, you said the software is good, and that model embedded in a microservice, defined and deployed as an endpoint, can score just any other data that comes in on the fly and gives you the required or desired outputs. Friends. And finally, the models now are no longer standalone, and therefore they are being fed into your other application workflows. And so therefore, the model need not even give out any specific data to you, but that model output is taken by other application, and that application consumes, and that application calculates whatever it is supposed to calculate. Say, for example, in the insurance financial domain, right? So the model does the underwriter's predictions, and insurance has been issued in seconds, right? So which earlier used to take a lot of time because of the manual inspection. Okay, now I just want to quickly move into the important one. Why? Because almost last 30-40 minutes, we looked at a very clear stance on how the standard of machine learning comes into picture. Therefore, we look at the data variations, data modeling, and then we look at the machine learning AI model itself, and how do we spin it, and probably again what types of models can be there, and then how do we consume those models and the output data into our applications and use it. So this is all one single stance, end-to-end stop there. But then the requirement, right? Again, we are all greedy. Therefore, organizations, people, everybody said that, all this is good, but we also want to do something more, something different. How can that be possible? Then when you ask, what is the different? The difference comes in addition to develop, in addition to test. Can that happen on a continuous basis? Again, go back, friends, and recall that we said change is the constant, right? So things are changing. I know that my data is changing, so we again spend. So we know that data can be drifted, data can be incremental, data can regularly change, right? Or there can be outliers, whatnot. In all these ways, if your data is changing, if your application requirements are changing, right? So earlier we said, yeah, I need the sales predictions every month. So the model was saying, okay, once a month I will predict. And suddenly you decided, why every month? I want prediction every week. I want prediction every day, right? So can you give me my sales numbers on a daily basis? Can you give me my customer footfall on my website on hourly basis, right? On every minute, every second. So what stops you to refine and redefine the granularities on the fly, and then how will you make that happen? How will you realize? And that particular requirement has brought in this paradigm. So what you're asking is seamlessly, I want these changes to be incorporated, but my application which is having embodied models inside, should work without going down, and then I still see the result. But whatever the changes I asked, whether the new data, new feature, new requirement, that should be like added, and I should see that. And that is what has brought in the continuous development and the continuous integration. And again, remember friends, so this CDCI need not even be specific to analytics, should have such a differentiated life cycle. No. Whereas earlier we had the patience, right? If any of you can recall, whether it is Red Hat versioning, the Linux versioning, or whether it is the Windows versioning. So the versioning used to take time. So we had Windows 95, then Windows 97, then 2000. So imagine like 2 years, 3 years time you have for you to see a next full-fledged version that is being changed from the earlier one. Whereas today, your whatever the Windows 10 to Windows 11, do you see your software going down, or are you really like so putting the entire dissolving the 10 to 11 or anything like that? These are just on the fly patches or on the fly updates you do, and then here you go, like so you have a new entirely upgraded system or software ready for you. And that is what that seamless paradigm is targeting and looking at. So therefore, the continuous development, continuous integration is what is being asked as the next ask, which is taking us from analytics development to the MLOps. So the machine learning operations, right? So here you see, so purposefully I put 3 circle point, but if you don't like it, the data engineering, you're free to take the data engineering out, because the most important common 2 terms would be the machine learning and the dev operation, the development operations, which are in vogue. And there is some commonality that is being taken for the machine learning operations. And now the question why I purposefully introduced data engineering is, again, heavy part of it, right? So there is a little bit of machine learning role to play, or even the UI or the app integration to play. But the predominant role, the predominant change you see is with respect to the data itself. Therefore, the data engineering facets are important even to the MLOps, and they come handy. And hence, when you would like to differentiate and look separately the DevOps and the MLOps, we would like to see that as the tripartite Venn diagram here. And as you could see here, the MLOps is having some common features of DevOps, but it's also standing out, again, by virtue of its the endpoints, APIs, and the modeling features involved with respect to the MLOps. So then, once we now talk about MLOps, as I said, the machine learning operations are nothing but the development on the continuous basis. So once we know that that is what the standard or the general requirement / the operational feature, then we have all the players coming in. And today, of course, we have 3 major players, right? So as you all know, that is Amazon we have, and the Microsoft Azure we have, and of course, the Google cloud platforms. And all of them have have their own wrappers, but ultimately, if you really put them one next to other, you more or less see that the typical steps, the workflow will still cater to the broader abstraction what we talked about, right? So because whether it is AWS or Azure or GCP, they cannot be out. They have to have what is called as the model registration. They need to have what is called as the data source, data sync. They need to have the. It is actually helping to have a healthy competition. And then, so one is propelling the good features, enhancements to the other. So I would see that as a positive, want a better word, still kind of collaboration, though it's not really collaboration, but at least one party or partner is helping the other partner also to come up in case they haven't realized some of these features. So, but typically the cloud platform, right? So if you look at the AWS platform is looking at the data preparation, and you have a block that is looking at how do you train, how do you tune. I'm sure this is what you see as I was saying, right? So the abstraction, what we captured, you will invariably see only thing with a lot more detailing, right? So because of course the devil is in the detail. So it's what? So that has the algorithm selection. Then you need to have, shall be doing that initially in your local systems. Then you shall be hosting them onto the cloud environment. And then you define the workflows, you define the endpoints, and then finally we create the model artifacts and then create the model registry and make that available for the productionization and the consumption. Presented to you the Azure database point of view. Only thing is, as I was saying, right, so the way they looked at it is slightly different. So it still has the same requirement of the data prep, modeling, and then deployment. But the Azure and Databricks, while they realized the MLOps, they wanted to have a very clear-cut separation and said that we shall have something called the development environment, we shall have something called staging environment, and then we'll have what is called a production environment. And again, friends, let me tell you, my experience has been nice and good with several organizations. Actually, in the industries, we looked at it, and they all very religiously. I remember, mind you, it costs, but still people are ready to put the cost there, put the money there to create the necessary layers here, and then the names can differ. So they call that as, okay, the development layer would be the bronze layer, the staging environment could be the copper or silver layer, and something else is the gold layer. The production environment would be gold layer. So you give different names, but essentially you cater to the typical 3-layer or 3 environmental architecture becomes your typical standard enterprise way of looking at most of this AI, machine learning, ML developments, and then finally consume the development into their other application integration process. But the steps won't differ. So it is only the way the repeatability has been defined. So in some of the MLOps environments, you do one-time development and then the testing in different environment. In some other places, you take the piece of code and promote the code from your development to staging to production. So that is how it goes from again, the vendor to vendor, the platform to platform. But as a reiterate, so you still will have cater to all the features that are required for MLOps to succeed. That is starting from data to the model iteration, to the versioning, to the deployment or the app integration. Again, the third, even the Google platform to cater in the same fashion. So it does look at the versioning. I think apologies for a little unclear one, but I given the reference URL. So offline, probably you can take a look at it, and then you can see that it is also catering to your data engineering model outputs that are being generated. So I try to give that perspective on all the 3 platforms. So we have the AWS platform for the machine learning, we have Azure platform, and we have even the GCP. Then a couple of slides I just wanted to introduce, right? So there were 2 very popular MLOps tools, right? So that is what I would call that as top of the mind recall. There is, interestingly, there is something called MLflow, and there is something called Kubeflow, which are quite popular today, that several organizations choose to implement. There are organizations where we have implemented Kubeflow, and there are a few other organizations where we implemented MLflow. And just for your information, MLflow has been actually taken by the Databricks, and therefore that becomes a kind of more cohesive and homogeneous offering between the Azure, Databricks, and MLflow. Whereas the Kubeflow offering pure open source standard is being leveraged more heavily by the GCP and AWS. So therefore, for a railroad customer, actually, so we made that offering and using SageMaker, right? So we help leverage the Qflow, and then SageMaker, Qflow, and AWS makes a good combination, good stack, MLOps stack for them, and they could again derive the results. So just again to enable the audience to know, right, the several roles which we typically look into in this ecosystem are like the data governance officer, the data engineer, the data scientist, ML engineers, and the business stakeholders are typically the people who play a role and who